Now, just taking a look at our website, I'm still in this section here. And there's a small few slides that I need to finish in this set of slides. And then I'll move on to this set here. This week's lab is this one over here, where we will be developing a serverless web API. And that's actually going to be the basis for the first assignment. I've published the specification for the first assignment on Moodle, and I'll talk about it briefly at the end of today's lecture. So we're going to pick up the story with this set of slides here. And what I want to finish up is on DynamoDB. So we know that DynamoDB is it's actually only one of AWS's serverless database services. It has others as well. And what's characteristic of DynamoDB is that it's a NoSQL database. It's very different, though, from any other type of database, well, that you would have used up to now, be that relational or non-relational. It doesn't have, in particular, it doesn't have anything as sophisticated as SQL for querying the database. And it's on that point that I just want to finish off on. There's an awful lot about DynamoDB that we're not going to cover. And mainly, well, I guess there are two reasons: we don't have time, but also this isn't really a database module. So I don't want to get bogged down on database issues, even though a database is going to be part of the first assignment. But I don't think that's going to be the challenging aspect of the first assignment. So just one sec now. All right, now just give me a moment. If I pick up the story sort of here, let's say here, yeah, we know this already. I've covered this already with you. What I'm saying on this slide is that there are three types of operations that you can carry out on DynamoDB. And let's think in terms of read operations rather than writing or updating. In terms of read operations, you can either perform what's called a single item read operation, and for that case, you would have the full primary key of the item. Item, remember, is equivalent to a record. You would have the full primary key for the item, and so obviously the result of such a read would return one item. There are query type operations as well that you can carry out. Again, a read operation. And a query operation returns more than one item, but all of those items are going to be from the same partition. And so for a query operation, what you want to do is you want to get a set of items that have the same partition key, but the sort key has a range of values. Also, I should say that a query operation is only relevant when the table's primary key is a composite primary key. Now, all this composite primary key goes back to this slide here. Remember, we talked about there are two types of primary keys that might be associated with a table's design. There's the simple one where the primary key is the partition key. The second option is where the primary key is a composite of the partition key and the sort key. And we know what the significance of the partition key is in relation to DynamoDB. The partition key dictates which partition an item is stored in. And that relates to this slide here where we said a DynamoDB table is actually spread out over a number of partitions for performance reasons. Okay, so we kind of know all of that already. So if I go back to here now, sorry for jumping around, but when a table's design is option 2, then it's only for those types of tables that you can perform query operations. They only make sense for those types of tables. Okay, so if I go back to the slide that I started talking about, which is this one here. Sorry, this one here. So query operations only make sense in the context of tables whose primary key is a composite key. And I want to talk a little bit more about that in a moment. Scan operations are essentially where you want to read all of the items from a table, and that might be a useful thing in some cases. Obviously, for very, very large tables, it wouldn't be a very good operation to perform regularly because of its inefficiency. So, picking up the story with these query operations, I had another slide which I've also discussed in the previous lecture, and this is kind of reinforcing the point that I've been making, that a query action or a query operation, it only applies to tables whose primary key is a partition key, and the query can only be based on the partition key part of the primary key and the sort key part, of the item. You cannot express a query which is based on other attributes in the item. Okay, that's just not possible with DynamoDB. With relational databases and SQL, it is possible, and the database engine can actually parse those types of queries. But for DynamoDB, you're much more restricted. And so these types of query requests, you've got to specify in the query request what is the exact value of the partition key of the items that you're looking for. So that has to be an equals operation. And in terms of the sort key part, you can specify a range of values. Now, if the sort key is a numeric type, then the range can be expressed using these standard less than or equal to, etc. Operators, or indeed the between operator. If the sort key is a string, then you can specify a range in terms of what the string begins with. That's the only option available to you. There isn't an ends with or contains operation available to you, unfortunately. Now, for query operations, maybe you might get back more records than you're interested in which case you can actually perform, I'm saying here, you can perform filtering of the items, but that filtering is done on the client side. The DynamoDB engine itself is not able to perform filtering, and typically the filtering would be based on the other non-key attributes associated with the items that have been selected. Now, if I go forward now to this slide here, which is stuff that I did not cover in the previous lecture. In DynamoDB, we have these notion of local secondary indices, or LSIs. And a local secondary index is an index based on using an alternative sort key to the main sort key that you would have associated with the table design. the partition key still applies. So an LSIs are based on an alternative sort key, or they're also called a range key for a table. These local secondary indices, they're built up by the DynamoDB engine as you add items to a table. So it manages the LSI for you. The thing though, the reason we use local in the name of these indices is because a local secondary index is stored in a partition, but it only relates to items on that partition. So if your database is broken up into 4 partitions, then a particular LSI will be broken up into 4 parts. Each partition will have its own LSI for the table. I'm saying here you can have a maximum of 5 LSIs per table. So if we had 5 alternative sort keys that made sense, then we can design 5 LSIs. And these local secondary indices, the reason you would actually include some local secondary indices in a table's design is because your application needs to query items from the table based on different criteria. And the criteria would be linked to the alternative sort keys. That's really where we're getting at here. So the LSIs facilitate the types of queries that your application needs to perform against your database. Well, this point I've hopefully already made. These LSIs only relate to query type operations. They don't relate to scans. And really, as you'll see in this week's lab, when you encode a query operation using the DynamoDB SDK, one of the things you can specify in a query request is which particular secondary index do you want the DynamoDB engine to use when it's selecting items from the partition. The attributes chosen from the LSI key. Well, okay, that's the same as with the main index. This is very important. Your LSIs must be defined at table design time. You cannot decide after you've created a database and added some items to it. You cannot then decide, I actually need another local secondary index for this particular table. So they must be chosen at table design time. Because as I said there, as items are added to a table, the DynamoDB engine will populate the local secondary indices, plural. So that's why you cannot add them after items have already been added to a table. And so what that means is that overall, a table, I'm saying here, it can have a primary or main index. It can have optionally a number of local secondary indices. And there's also something called global secondary indices, GSIs, which we won't look at, but that's an option as well. GSIs, though, are different from LSIs in many ways, one being that GSIs are not stored locally on a partition because global secondary indices relate to items across partitions, so they're not as efficient as LSIs. And so if you create a table and it doesn't have any local secondary index, by default, it does have one index, which is what I'm calling the main or primary index here. So there is always an index, even when you've got a table that doesn't have any explicit local secondary indices. Just an example, and I've literally taken this straight out of the DynamoDB documentation, online documentation, so you may come across it if you Google around this. But supposing we've got a table that contains discussion threads. And so here's an example of maybe some items in this table. So the table's partition key is forum name, it's a string in this case, obviously. And just for simplicity's sake, we're using some of the various AWS services as forum names. The sort key is decided to be the subject of a particular thread, again, which happens to be a string, just coincidence. So that combination then of subject name and forum name, that is the primary key for this table. And there are some other attributes as well. In particular, there's this attribute here, and there are some other attributes. Now, if we decided we want to have a local secondary index where the sort key is actually based on this last post date, so we could visualize that alternative index as looking like this. Okay, so the partition key for our local secondary index is the same partition key as the main index, but the sort key is now this last post date. And then the other attributes are as before. What this local secondary index would now allow me to do is it will allow me to submit query requests to this table where the query might be, give me all of the threads related to the S3 service where the date of the posting begins with, let's say, 2015. Whereas if I go back to the main index, what this allows me, the only types of queries that I can perform against this index is give me all of the discussion threads related to the S3 service where the subject of the thread begins with some substring. Okay, there are the two types of query operations that I can perform against this particular table. And I can perform both of those types of queries because I have a secondary index, a local secondary index that supports the query, which is saying, give me all of the threads related to a particular service where the date of the last posting on that service begins with a particular year or maybe year and month. We're storing date here as a string. The DynamoDB doesn't have a date type. So that's what LSIs are for. They allow us to query our table on different criteria using different attributes of the items. Obviously, these local secondary indices, you know, the constraints, certain constraints still apply. In other words, for example, the combination of forum name and last post date, that combination has to be unique across all of the items in a table. So this combination here is, if you like, it's an alternative primary key, although we don't talk about it in those terms. But that the combination does have to be unique. Okay, that's really all I want to look at in relation to DynamoDB. Now, if you're a little bit unclear about local secondary indices, then in this week's lab, you'll get an opportunity to implement to define them because they are essentially they're part of your infrastructure for the DynamoDB for a DynamoDB table, and you'll also see how you can query a DynamoDB table using an alternative or using a local secondary index as opposed to the main index. Right. That's that. Now, if I go back to my website, and I want to move on to these slides here, but we're still talking about serverless in general. And we're talking about services that serverless services that DynamoDB provides us with. I'm just going to stop sharing my screen for a second so that I can switch to the other slide set. Right, so continuing on with our look at AWS serverless services. We've looked at Lambda so far. We've looked at DynamoDB. The next service I want to look at is API Gateway. So what I'm saying here is that if you want to develop a serverless application in very general terms, there are kind of three parts to any application, be it serverless or otherwise. We're talking about serverless here. There's the logic part of your application. In other words, kind of the functionality associated with the application. Now, we've seen that it's the Lambda service that will allow us to implement functionality for a serverless application. There are other serverless logic-based services, bit of a mouthful, but for example, there's a service called Fargate, which allows you to implement your logic using containers like Docker, hosted on a serverless platform. We're not going to get to look at that though. Another aspect of any application is state management, and we've just been looking at that. So DynamoDB is a serverless service that allows you to manage the state associated with an application. You could also regard Amazon S3 as a state-related serverless service. And as I said at the very beginning of this lecture, there are relational database services that have a serverless theme to them, but we're not actually going to look at any of them. At the bottom, then I'm saying the third part of any application is what we're calling communications. And in other words, how do we get the different parts of our application to communicate with one another? And in that vein, one serverless service that deals with communication is API Gateway. We will look at some of the others later on in this module, SQS and SNS. We won't look at Kinesis at all, but these other services over here are very interesting as well. And there are aspects to them that you will not have come across anywhere in your studies so far. API Gateway is going to be make a lot of sense to you, especially because of the web app dev module that you studied in the previous semester. So it's this API Gateway, that's what we want to look at in over the next set of slides. And what API Gateway will allow us to do is, I'm saying it will allow us to implement a kind of classic three-tier serverless web API. So we have our client. Our client might be a React application or any other type of client. It could even be a mobile native app. Doesn't have to be web-based. In the middle, we have this API Gateway service, which is kind of the entry point into your web API. We have lambdas, so you can imagine now that you have many lambdas, not just one. Many lambdas that are connected or with the API Gateway. You have a single point of entry, though, to these lambdas. And we've got some sort of database or state management on the extreme right. And in our case, we'll probably use DynamoDB. So that's your classic three-tier serverless web API. And so we want to look at how do we set up this API Gateway to complete, because we know about lambdas, we know about DynamoDB, we know how this communication works here. Now, I know in the in my earlier lectures, we had a way of interacting with a lambda directly by creating a URL unique to a lambda. And that URL allowed a client to send requests directly to the lambda. But if you've got many lambdas, then you can't really follow that approach, because each lambda will have its own unique URL, and that's a little bit more difficult to manage. Whereas when you introduce API Gateway, you now have a single point of entry. So in a sense, you've got only one URL to deal with from your client's point of view. So this API Gateway service, what is it? It's a fully managed, and I've said before that fully managed is a byword for serverless. So there's no creating any kind of physical infrastructure required. Fully managed service for web APIs. So if you want to create a REST web API endpoints, then API Gateway is the route you should go. API Gateway does an awful lot more, though, than just that. Now, we are only going to look at its support for web APIs, but it has many other aspects to it. For example, it supports WebSockets, the WebSocket protocol. That's a protocol that allows for server push operations. API Gateway also supports versioning, so you can have different versions of your API available to your clients. It supports different environments, as in a dev environment, a test environment, prod environment. You can call the environment anything you want to. That's all built into API Gateway, should you want to configure it. It has authentication and authorization aspects to it. We will be interested in that, but we need to look at another service before we can deal with that. But that is built into Web API, or to API Gateway, sorry. What else? Oh yeah, API keys. Like the normal way for authenticating with a web API is using some sort of username, password set of credentials, but you can actually have API Gateway generate API keys, and then your client uses the API key that has been assigned to it as a means of authentication. Again, we won't get an opportunity to look at that. It understands Swagger, if you're familiar with Swagger or OpenAPI. It can perform transformation and validation. So if I go back to the previous slide, so that there may be data included in a request sent from the client to API Gateway. API Gateway can perform transformation of that data if necessary, transforming it, let's say, from XML to JSON, or JSON to YAML. It can perform validation of that data, although that's frowned upon by some people. Some people feel that validation is really, that should be done by your Lambda rather than API Gateway, but the option is there. You can also generate SDKs for your web APIs, which we won't look at. It can perform caching. So lots of aspects to API Gateway, lots of configuration options available to you. Now, as I said, unfortunately, many of them we won't get to play with though. So your API Gateway is going to it needs to integrate with what might be generically referred to as the back end of your application. Now, the back end of our applications will always be Lambdas, but it doesn't have to be Lambda. It could be an application load balancer. It could be an SQSQ. There are lots of integrations possible with API Gateway, and hence API Gateway has lots of integration types. Now, kind of a default one is what's called the mock integration type. With the mock integration type, your API gateway doesn't really pass a request onto anything, onto any backend. It just generates a kind of default response itself. And that default response is sent back to your client. So you might use the mock integration type if you were just doing some basic testing of your API gateway. So that's not too interesting, and we won't be using it. Another integration type, and unfortunately, the names given to these integration types can vary depending on what article you're reading, but I'm just going to call it the HTTP AWS integration type. And so you might use that, for example, if you look at the image down at the bottom, if you want to integrate API gateway with an SQS queue. Now, we haven't looked at SQS queues, but it's it's a messaging service provided by AWS. We will be looking at SQS queues later on in this module. If your integration is of this type, though, what API gateway needs to do is it needs to transform the HTTP request into another form that is suitable for your backend. And that transformation is expressed using what are called mapping templates. So you have to create these mapping templates. It's a form of code, really, but it's declarative rather than imperative code. You have to declare these mapping templates that express how requests should be transformed into the appropriate form so that they can be passed on to your back end. And equally, the response that comes back from the back end, they have to be transformed back into the HTTP form that is required by the client. And that's all done by these mapping templates. They're quite verbose, these mapping templates, from what little I've looked at them. The next integration type is AWS proxy, and this is the one that we're going to be using. And so the characteristics of this AWS proxy integration type is your request is coming in over HTTP, and that HTTP request is essentially proxied on to your backend, which in our case and in most cases will be Lambda. So the backend understands HTTP communications, if you like, and it will respond with a HTTP response. So there's no transformation being carried out here, so you don't need these mapping templates for this type of integration. The other important point is down here, I'm saying that HTTP headers and query strings. So the request that comes in from your client, it may quite often does include HTTP headers, and we want to make those headers available to our Lambda. But what the API gateway does is it packages those HTTP header information, it packages them as parameters of the event that is made available to your Lambda. And we will see that a little bit later on. Also, if the request includes a query string as part of the URL, and we know that a query string is a set of key value pairs, then those key value pairs are again packaged up by API gateway, and they're made available to your backend as convenient kind of arguments within the event object that's made available to the Lambda. And we will certainly see examples of that, and it's important that we understand that that role that's performed by API gateway. So everything that's essentially, I guess I'm saying in summary, everything that's makes up the HTTP request, whether that be a HTTP body, query string, headers, request headers, all of that information is made available to your Lambda in the form of properties of the event JSON object that is accessible by the Lambda. So that's AWS proxy. There is another integration type called HTTP proxy, which we won't be looking at either. And in HTTP proxy, whatever form the request is coming in at, that exact form is passed on to the backend. So there's no kind of wrapping up of the query string or the headers into nice convenient key value pairs that are made available to your backend. The actual raw HTTP request is simply proxied on to your backend. And an example of a backend might be an application load balancers. There are no mapping templates here either. So there's lots of integration types. The only one that we're going to use is this one. But just be aware of the others, I guess. It's very important that you configure the CORS setting for your API, your web API. We know what CORS is, cross-origin resource sharing. So you do, when you create any web API gateway is a service that allows us to create a web API kind of front end, if you like. And in that configuration, as we'll see, you do need to state what is the CORS configuration for your web API. And just a quick, this image is just a quick reminder of what CORS is all about. So on the left, let's supposing our client is a web client, and its domain name is that. And on the right, then I'm saying, let's supposing we've got a web API, which is which we create using the API gateway, and its domain name is this. So there are two different domains. That means if our client wants to communicate with this web API, then we need to indicate will the web API actually respond to this client, seeing as the client is of a different domain to itself. And so the way we do that is we configure the CORS setting for the web API. We know how CORS works. So when this code, which let's say I'm just using an S3 bucket here because you can host a web application, for example, a React application, you can host it in an S3 bucket. So when that web application is loaded into your browser, and somewhere within the runtime of your application, it wants to send a request, be it a GET or a POST request to your web API, then the way the browser actually implements that request is it first of all sends a pre-flight request to the web API, essentially asking it, will you support requests from this other domain? And the web API will respond saying what support it provides for that domain. So it looks like in this case, it supports all the different types of HTTP methods for that domain. So that now means our browser knows it can now send the request to the actual web API, and it then sends on the actual request to the web API. So this pre-flight stuff, this pre-flight request and the response from that request, that response is generated based on the CORS configuration that you have expressed for your particular web API. Let's take a simple example. Suppose we've got this web API and it's an API for managing to-dos, your classic kind of 101 example. And I've decided that my web API will have two endpoints. One endpoint is the /todos endpoint, and it can have either a GET request to that endpoint or a POST request to that endpoint. If it's a GET request, then essentially our client wants to get all of the to-dos stored in our database. Let's assume it's a database. A POST request to this endpoint is the equivalent of wanting to add a new to-do to your database. If the endpoint, if the structure of the endpoint is like this, slash to do slash, and then some sort of value, where the value represents the identifier of a to do. Let's say it's the partition key value of the to do item. And if it's a GET request, then that's equivalent to saying we want our backend to return a particular, the full details of a particular to-do item in our database. Okay, it's all fairly standard kind of stuff. So our web API has two endpoints. This endpoint supports a GET and a POST request. This endpoint supports a GET request. This endpoint also has a what's called a path parameter part to it. And we know what the path parameter value, what its meaning is. Now, I'll show you in a few moments what CDK code we need to, if I go back, how do we kind of express this in our CDK code? I'll show you that in a moment, but when we have written the CDK code expressing this structure for our web API, and when we deploy it using CDK deploy, then what we would do is look at the API gateway service, which is just another service. And we'll see in the list of APIs, we'll see hopefully our API, whatever name we gave it. And when we click on that API, then we're brought to this part of the API gateways console. And we can see the actual structure of the API, which is consistent with what I showed you on the previous screen. And, I've actually, I go over to VS Code. Here's the little my project that contains my web API implementation. Now, in my case, am I look at the right one? Yes. In my case, I just have, well, sorry, if I go back, if I go back to here. Ordinarily, I guess we'd have a Lambda that is integrated with this, another Lambda that's integrated with this, and a third Lambda that's integrated with this. Okay, because we need to integrate our web API with some backend, and we're going to be using Lambdas as our backend. So we would expect to have three Lambdas. We'd expect to have a database as well, where those Lambdas are talking to that database. But I'm not really interested in that kind of aspect of our web API. All I'm really interested in is the API gateway part of our web API and how we configure API gateway to create a web API for us. And the reason I'm mentioning that is if I look at my mini project that's implementing this web API, and if I go into the Lambdas folder, I only have one Lambda there, and it's really just a kind of dummy Lambda. It doesn't do anything. I collapse that. It doesn't do anything. It just console logs the event that triggered the Lambda, and it just returns a standard message saying, what's the message saying? The message is saying success. Right, that's all the Lambda is doing. So in fact, each of my, sorry, now we're jumping around, each of my endpoints, sorry, now, how do I erase that? I really only have one Lambda, and each of these is talking to that same Lambda, or is integrated with the same Lambda, and the Lambda does nothing other than just responds with a success response. There's no database. Okay, so and the reason I did that is because we're not really interested in the Lambda in this discussion. And I have already done a CDK deploy. I haven't shown you the infrastructure code yet, but I've done a CDK deploy. And what I get back from the CDK is the URL of my web API, which I get from here. Yeah. So if I click on that, now, so here's the URL. And the reason I'm getting this response is because I don't have any integration for the root path of my web API. I only have integrations for the /todos path and the other path as well. So, but if I add on /todos, now, where did this come from? This came from the Lambda that I just showed you there a moment ago. So it looks like my Lambda is integrated properly with this endpoint. And if I look at the other endpoint, which would have the other endpoint would have a to-do ID. And we don't have any to do, so anything will do really. I'm getting back the same response, and that's because it's the same Lambda that's been triggered in both cases. But that's enough for me to realize that it looks like my web API is working. Now, I need to show you, though, the infrastructure code for creating the web API. And that's what you see on this here. So as I've already covered the Lambda stuff. And so, it's uh, fairly intuitive, I would hope. So this is just creating an empty web API, if you like. Give the API some sort of a web API, some sort of a name. And the only thing of importance is maybe this part here where we're uh, the, where we're configuring the core setting, and I'm essentially saying any client can issue a request. Any client can issue a request to this web API, and any of the HTTP methods will be accepted, and the web API will respond back to it. So it's a fairly open API, if you like. The other aspects, description, that's okay. Remember I said that the API gateway supports different environments. Well, it looks like this API I'm currently developing is for a dev environment. That's fine. The next line here, down here, then is where I start building up my set of endpoints. And here what I'm doing is I'm adding the to-dos endpoint, and I'm adding it to the root path, which is just a slash on its own. That endpoint, I'm further expanding on it here. I'm saying that endpoint supports a get method request. And for that combination, a get method request to this endpoint, I'm now integrating that with a particular backend. And because I'm using a Lambda integration, that really is equivalent to the AWS proxy integration that I mentioned a few slides back. And that's the only type of integration we will be doing. So this is how we connect up a Lambda to a particular endpoint for a particular method. And I'm just doing some more integrations further on here. So this looks like the integration for the post, for a post request to the to-dos endpoint. I'm adding on here, I'm adding on a new endpoint. So all of this here relates to the to-dos endpoint. And what I'm doing down here is I'm adding an endpoint or a resource. Resources, the two terms are interchangeable in the world of web APIs. I'm adding a new resource, but I'm adding this resource, I'm adding it onto the resource that I've already created. This to-dos resource is the one that I created up here. And the path for this resource, because I'm wrapping the path in curly braces, That's my way of expressing that this particular part of the path is going to be a path variable. And in my case, the path variable represents a to-do ID. And so on. Okay. I'm only supporting GET requests, though, to this particular endpoint. And I'm integrating it with a Lambda, which happens to be the same Lambda. Sorry. Okay, so it's long-winded enough, I suppose, but I do think it's fairly easy to understand. And so at the end of all of that, at the end of all of this code here, I now have two endpoints. I have my to-dos endpoint from I have my to-dos endpoint from here / to-dos, and I have my to-dos / to-do ID endpoint from here. And that's it really. I do not have to explicitly output the URL of the web API that's created for me. That's automatically, in other words, when you see here, it's giving me the URL of the web API. That was actually this whole line is generated by is generated by is generated by essentially this line here. Okay, so that's how you create a simple web API, and we're integrating it with a Lambda backend. And there's nothing further, there's no database in this particular little example. But in the lab, you will have a full 3-tier web API that you will build up. Now, quite often we want to use a query string as part of a request to our web API, and our query string might look something like this. And the query string, as we know, is a set of key value pairs. And so the question is, how does this query string, how is that made available to our Lambda? How does it access it? And this is a point that I mentioned a couple of slides back. The API gateway will take the query string and it will parse it into a set of key value pairs, and it will add those key value pairs as a simple JSON structure that you can now access within the event object that's made available to your Lambda. And so all I'm showing you in the screenshot down here, because again, if we flip over to our Lambda, the Lambda is no different from before in the sense that it gets an event object here. So what I'm showing you on the PowerPoint slides is I'm looking at the console log of that event object. And if you scroll down, you will find within that event object, you will find a key called query string. You can see it here. And that query string will be initialized. Sorry, no. That query string will be initialized based on the actual query string that appeared on the request that arrived at your web API. And API Gateway does that parsing of the query string and putting it into the event object for you. And the key value pairs can be anything really. Equally, if your URL request includes a path variable, and one of our endpoints does, because we want that's a path variable in our case. So again, the question is, how does our Lambda get access to this path variable value? Well, by the same argument, the API gateway will make it available within the event object. And in this case, we can see in this screenshot, we can see here, there's a path variable part, and it has, again, a key and a value. The key here, the key is based on whatever variable name you used here. This is essentially kind of a variable name. So they are two of the nice supports that API gateway provides for you, parsing of the query string and also making path parameters available to your Lambda. Right, where are we on time? Okay. I think I need to, let me just look now. Yeah, I think I can just move on to the next service. The next service is a service called Amazon Cognito. So what's that all about? Amazon Cognito, I've actually kind of squeezed it in here as another part of the state management of an application. And in this case, it's a particular part of the state aspect of an application. It's the users of your application, their credentials essentially. So Cognito is what is going to provide the authentication and authorization support for our application. And in our case, our application is going to be a web API. So it's going to manage our users, our set of user accounts for our web API. So so if you've got a web API, clearly you want to give users the ability to access it, and you want to give them some identifiers, or you want to give users an identity. And Cognito will do all of that for us, and it'll manage all of the kind of standard authentication and well, in particular, the authentication aspects of a web API, like login, sign up, reset passwords. All of those standard aspects can be managed for us by Cognito rather than we managing them in our own Lambda implementations. Now, in the world of Cognito, we have what are called Cognito user pools. Really, Cognito, in a sense, is a bit like a database of your user accounts information, but we don't treat it as a database, or we don't interact with it as a database. Cognito takes care of all of that. So what Cognito talks about are what are called user pools. And that's what we will do. We will create a user pool for our web API, for example. And the user pool, that Cognito service comes with lots of the kind of standard aspects to it, like sign in functionality, sign up functionality. It integrates very well with API Gateway. You can use it for other types of applications as well, but we're particularly interested in integrating it with API Gateway. Cognito also has this concept of identity pools, which we won't look at, but identity pools are useful if you want to give users their own AWS credentials, like secret key and access key and secret access, secret key combinations. Okay, there may be cases where you want to give users their own set of AWS credentials so that users can interact directly with some of your services. Like, for example, if you want to allow a user to upload files to an S3 bucket, then in order for a user to be able to do that, that user needs to have a set of AWS credentials. And so what the Cognito Identity Pool service does is it generates short-term AWS credentials for users to allow them to interact directly with your parts of your infrastructure. But as I said, we won't be looking at that. We're more interested in the Cognito user pools side of the Cognito service. In a way, there is an overlap between people often kind of confuse what's the difference between Cognito and IAM, because IAM is all about giving users identity, and that's the word I used up here specifically about Cognito. So when would you use IAM for managing users as opposed to Cognito? And a very simple rule would be if you've got a large user base, then you should use Cognito. If you've got a very small user base, then maybe IAM would be fine as a way of managing your user accounts, if you like. So we're only interested in Cognito user pools, and a Cognito user pool is as a term that I used there a few moments ago. It's essentially like you could think of it as a serverless database of your users for either a web application or a mobile application. It's very like Firebase if you're familiar with Firebase from your mobile app dev studies. Essentially, Cognito user pools are an alternative to Firebase, and arguably Firebase is a little easier to use. But either way, AWS's service in that space is the Cognito service. It supports your standard kind of simple login functionality, username and password combinations. It supports password resets. It supports email and phone number verification, and we'll see that actually. The idea is user signs up for a particular web API, and the web API or the web application sends an email to that person containing a code, and they use that code as verification that they are the actual owner of that email address. Supports multi-factor authentication, which we won't get a chance to look at. You can configure the Cognito user pool such that you use maybe some of your social media identities as a way of logging in, i.e. your Facebook identity, Google identity. Again, we won't get an opportunity to look at that though. And you can do things like block user accounts, include JSON web tokens. Well, we will see that in action. So the way it's going to work is, again, fairly standard. When a user logs in to an application fronted by a web API, they provide their username and password credentials, and then the Cognito service will generate a token, a JWT token, and that token then can be used for any subsequent requests from the client as proof that the user has already logged in. So in very kind of high level terms, this is where Cognito fits into the kind of application infrastructure. Your client, first of all, communicates with Cognito, providing your username and password set of credentials. Cognito validates those against against the particular user pool. It returns a JWT token or some form of token. It'll be JWT token in our case, back to the client. And that token then is used for subsequent requests to an API gateway. And the API gateway will extract the token from the request. It'll ask Cognito is this a valid token? And if Cognito says it is, then the API gateway will forward the original request onto your Lambda. Again, fairly standard process. That's a high-level look at where Cognito fits in. This is a more detailed look at it, though, in terms of how things work. And this is a typical structure that we use for web APIs that have authentication built into them, where the authentication is managed by Cognito. So what we tend to do is we tend to have two web APIs. One is specifically concerned with dealing with all types of authentication related requests. The other API, web API, is essentially a front end for the actual functionality of your web application. And again, the flow is as I kind of mentioned in the previous slide. Initially, the user will be sending HTTP requests to this web API. So your standard kind of login request. The API via some lambdas will communicate with Cognito. Cognito will respond. If it's a successful login, Cognito will respond back, and the Lambda will respond back to API Gateway with your token. That token is now sent to the client. For any subsequent requests to the actual functionality of the application, that will include the token, but this API web API here will have a Lambda function specifically concerned with checking that the token is a valid token. So this Lambda here, which we write, will need to communicate with Cognito to complete the verification of the token. And then if the token is valid, then the request is forwarded on to your protected backend service, your protected backend functionality. So it's this architecture. This is what we want to implement. And I have a lab that implements this full architecture. I think we'll make it next week's lab rather than this week's. But that lab is going to be an important part of the first assignment as well. Now, if I just flip over to VS Code, and what I'm going to do is, this is the actual code for the architecture that I've just shown you there. And I'm just going to do a CDK deploy. Okay, so we'll let that work away. Okay, so from a CDK point of view, this is how we create a user pool. Nothing too difficult about it, I don't think. We create a user pool. We're saying that users are going to use their email as a username. The self sign-in enabled, what that will mean is that users, once they sign up, they will also be required to confirm their sign up or their registration. We're allowing users to do that themselves. The removal policy, well, that's the same as with DynamoDB. We're saying here that once this application is CDK destroyed, then we want to destroy the user pool as well. Again, maybe for production environments, you may not want to do that. Now, as well as creating a user pool, you have to also create what's called a web client for that user pool, or an app, uh, uh, maybe, well, yeah, web client or just client in general. And the client that we're creating here will be used by any Lambda that needs to communicate with Cognito for the purpose of accessing our user pool. So you always need a client associated with a particular user pool. That's just the way the AWS people designed this user pool resource. And all we're saying is here, I guess, is that the form that user authentication is going to take is just your standard username password form. You can have a customized form of user identification, and we might look at that at some other stage, but for now we're just going to deal with your kind of standard authentication flow, as it's called here. The authentication flow is just going to be standard, i.e. you sign up with a username and password, and you sign in with a username and password. Now, so our application is going to have two web APIs. We talked about web APIs at the beginning. It's going to have two web APIs. One web API is solely concerned with dealing with authentication requests, and the other web API is dealing with requests for accessing the functionality associated with our application. We're not really interested in the one on the right, so I've just made two endpoints to the application web API, and the names will tell you something about the characteristics of them. So I'm going to have a public endpoint, and so anybody can access that. You don't need to have logged in to access that. And secondly, we have a protected endpoint, and clearly a user needs to log in before they can access that. There's no real functionality behind these two endpoints. Again, they're just two standard lambdas. One lambda just returns a message saying you've successfully accessed the protected endpoint. The other one says something similar. So it's the one on the left really that we're interested in. It has a number of endpoints, and you can tell from the names of the endpoints what each of them is dealing with. So if I take it from the top, not from the top down, but if we take, let's say, this one here, so /auth/signup is the endpoint that will receive requests when a user wants to sign up or register for this application. This one here is the endpoint that a user will send a request to confirm their registration. This one here, we're not interested in that one actually, as it turns out. This is sign out, obviously. This is, where's my login? This is sign up. Beg your pardon. This is sign up, and this is login. Sorry, I got those in the wrong order. This is sign up or registration. This is login. So number of endpoints, all related to the authentication aspect of our API. Just check again. Always. Okay, so it's successfully. And for this application, there are two APIs now, as we know, and that's reflected here. So I've got two sets of URLs, one for the auth API and the other one for the app API. And you just need to be careful. So it looks like this is the app API, and this is the, have I got those right? This is the auth API URL. Checking my time now again. Okay. Right. So before I start looking at the code, though, I'm just going to show you the how we actually authenticate using Postman. So I'm going to show you it working really rather than before I show you the actual uh, the code that implements, in particular, the authentication web API. And to do that, I need to bring up Postman. And you will be doing all of this in next week's lab. So in Postman, I've created a collection for myself, which is this collection here, the Cognito collection. And as you know, with Postman, when you create a collection, you can define variables associated with that collection, and you can use those variables in the various different types of requests that are associated with the collection. Now, in this case, I have three variables defined for the collection. The first one here, auth URL, I'm going to set that to the URL associated with the web API that handles all of the authentication requests. So looking at this architecture here, I'm talking about the URL associated with this web API. And I'm going to get that from the output when I did the CDK deploy. And again, I have to make sure I pick the right one now. Let's see. Yeah, so that's this one here. I'm going to copy that. And set it to that variable. I have another variable which is going to hold the URL of the other API, the other web API. In other words, uh, this one here. So if I grab that URL, and save it. Sorry, no, something in my way. We can ignore the third variable for now. So I've set up those two collection variables, and make sure you save them. And now I'm going to step through essentially the full authentication flow. So the first thing that a user would do is to sign up. And I've got a request pre-configured for that, which is this one here. And in this request, you can see that it's going to be a post request. And I'm actually using the auth URL variable that I have defined for myself at the collection level. And I'm tagging on the /auth/signup path to the URL because based on my PowerPoint slides, that would be, again, let's erase some of that stuff. That would be this one down here. That's the URL, or that's the path name that I'm supposed to use. And okay, sorry, no. Uh, the post request is going to have a body, and the body is going to be the username, the password for that user, that the user has chosen, and also their email address. Okay, they are required. Because I'm using the user password authentication flow, they are the three attributes that a user needs to provide on sign up. So that's my body. And if I send that request, now what Cognito will do is it will send an email back to this address, and the email will contain a code, whatever, a 6-digit code. And we need to use that code then to confirm that, to confirm our registration. And maybe before I do that, actually, if I go over to AWS, I know we're jumping around now a little bit, but if I go over to AWS, and if I go into the Cognito service, now because I've already deployed the stack, there should be a user pool there for my application. And if I go into user pools, we can see that there is one here. And if I go into that pool, and we can see currently there are no users in that pool. So if I now go back to Postman and I essentially sign up or register with this set of credentials, okay, looks like I got a 200 response. And if I look at my user pool at this stage, I do a refresh. I now have a user, but notice the user is unconfirmed. In other words, the user hasn't confirmed that they are the actual owner of the email address that was provided as part of the registration. Now, if I go to the email account that I used, which is my Google email, or my Gmail, sorry. So this email here is the one that was sent by the Cognito service. And if I open up that email, it's providing me with a code. And I need to use that code in my authentication confirmation request. How do I send that request? Well, back to Postman. The confirmation request is this form here. Again, it's going to be a post request. It's going to be to the auth URL with this particular path name. The body of the request will include my username and the code that has been provided. So I need to change this here to the code that was provided in the email. And if I send that, now is that don't like that response. Let's see. What have I got wrong? Oh, sorry. Let's undo that. Should pay more attention to what I'm typing. Let's grab that code again. Did it send it? Let's see. Okay, that looks a little bit better. If I go back to Cognito, and if I do a refresh, we can now see that the user has confirmed their registration. The next part of the process is I want to log in. And the login is going to post request to this particular path. And you provide your, excuse me, you provide your username and password. And if I send that, now when I send this time, it's going to, Cognito is going to generate a token, a JWT token. Now I've decided to include the token in the body of the response that comes back. But I've also included the token as a cookie. So let's just do it, I suppose, if we send this request. So here's the actual token included in the body of the response, which is okay, but you wouldn't normally do that. But if we look at the cookies that were included in the response, which you can access from here, and I've called the cookie, the key for it is token. So here's the JWT token, the full token. So if I copy that, because I want to use that token now in any requests that I send to access my functionality. If I just do a full select and copy, and again, as a convenience at the collection level, I'm going to save that cookie as a variable. So I've decided to call the variable token. I didn't have to, but the value of the token, though, is what I've copied from the cookie. So if I just get rid of all of this and paste that in. Okay, so that's my JWT token. Again, always remember to save any changes that you make at this level. So I've now logged in. I've got a JWT token, and now I can use that token to issue requests to the API at the bottom. And in particular, if I want to access protected resources. I have two resources, a public and a protected one. So let's try and access the protected one first and use the token. And so here's the request. So in this case, it's just a GET request. In this case, I'm sending the request to the URL of the application, not the URL of the authentication web API. And the path name is just /protected. Now, I have decided that my token, my JWT token, is going to be included as a cookie with my request, where the cookie's key is also called token. Probably should have used a different name, but it's also called token, and the value associated with that cookie is the JWT token that was provided to me. So if I look at the headers tab here, and if I scroll down, you can see here that I have included in my headers, I've included the cookie header, and the value is taking the variable, the collection variable that I defined up at the Cognito collection level. I could have pasted in the token directly in here. That would work as well. But I've decided to use the variables feature with Postman. Now, there are some other headers as well, which are actually mandatory. I kind of played around with them, but you also need to include the host HTTP header. I think that's the other important one. This is actually initialized for you by Postman anyway, so you don't have to work out what value should I give that HTTP header. The one that you set up is the cookies HTTP header. So I'm sending a GET request to this URL. I'm including some headers. And if I send that request, this response is coming back from the Lambda associated with the protected piece of functionality, and I can approve that to you if I just go straight into that Lambda, even though I haven't shown you the code yet. But the Lambda that is responding to that request is this one here. And am I looking at the right one? Yeah, so is that what I got on the in Postman? Yeah, so that looks like it worked. Can I prove to you that it's actually working? Well, if I go back to my token at this level up here, and supposing I actually make a change to the token that was provided to me by Cognito. So if I just make a tiny change, let's say, if I delete the E, oops. Supposing I delete the E there, so that now makes it an invalid token. Save my change. Go back to my request and issue it again. And I'm getting obviously an error message, and this error message is generated by API gateway because it's where the validation of the token takes place. Again, I'll show you the code that does that, but clearly it seems to be working anyway. Now, what I'm going to do now is I'm actually going to stop looking at this, and I complete our look at this sample project in next week's lecture. And the reason I'm doing that is because I want to switch over to Moodle and just briefly talk about the specification for the first assignment. So if you log into Moodle later on, and in the assignment section, you'll see here a specification for the first assignment. And so, surprise, surprise, the objective of the assignment is to design and deploy a serverless web API. And I've just chosen movie reviews as being the context for this web API, which is kind of linked to the web app dev stuff that you would have done in the previous semester. If there are any of you that did not study that module, that's not really important. Okay, and I also obviously want you to include the CDK code for creating the infrastructure for this web API. It's also going to be a secure web API, which means you're going to be using Cognito. It's going to be serverless, so you're going to be using Lambda, DynamoDB, and API Gateway. I've set that as the completion date. Assignment is going to be worth 40%. It's the usual deliverables, which you can read through yourself. Git is going to be very important, as is always the case with me, as you might remember. And then I'm giving you a detailed specification. So I'm telling you exactly what are the various endpoints that need to be part of your web API. Okay, so I'm giving you, in a sense, like I'm giving you the design of the web API. I'm doing that for you. So take it from the top. The web API needs to support post requests to /movies/reviews. And that endpoint should return all of the, what am I saying? Oh, sorry, it's for adding a new movie review to your DynamoDB database. This endpoint, get movies/movie ID/reviews, that should return all the reviews in your database for a particular movie. This one looks like I want to get a particular oh yeah, this is where I want to get all of the reviews for a particular movie where the minimum rating is greater than a particular value. So there's a query string involved there. And I guess you can, you can read through these yourselves. They should be fairly self-explanatory. So I'm giving you all of those. I'm saying that there needs to be authentication support built into this web API. In other words, using the Cognito service. Now, I think if you want to work on this assignment in the coming week, then you can really ignore the authentication part, because it's not until you have completed the Cognito lab for me that this stuff will make sense. And as well, I need to complete the lecture on Cognito. So there will be some authentication aspect to this assignment. Authorization, I've just arbitrarily decided that all GET requests to your web API are publicly accessible. Any post and put requests, though, require the user to authenticate or to log in first. And I think I've only got two, actually. I've got a post, and I've got a push here if you want to change your review. So there's only two endpoints that require authentication. This part here, Amazon translation, if we look at the various endpoints, one of the endpoints, which is this one here. So it's a GET request to /reviews/reviewer name /movie ID/translation, and the query string has a language key. And the idea here is that we want our application to take a particular review from our database, which has been written in English, but translated into whatever language the user has requested here. And there is an AWS service called the translation service, and that translation service will do the translation for you. So you will have a Lambda which will need to interact with this AWS translation service. It'll give it the text. The translation service will respond with the translation of that text, and then you include that translation in the response that you send back from this request. That translation feature now is obviously fairly high up in the grading spectrum for the assignment. And again, you can read through that. DynamoDB, I'm telling you exactly, look, these are the attributes of each item in my DynamoDB table. So again, I'm giving you that. And I am saying that the partition key is going to be movie ID. I'm giving you that. You can choose the primary key. I am telling you though that the combination of a movie ID and reviewer name, that will be unique, as in a reviewer will not write more than one review for a movie, which makes sense, I guess. So reviewer name and movie ID will be unique. Also, I'm telling you further on down here that movie ID and review date are also a unique combination, as in there won't be two reviews written for a movie that will have the same date stamp on them. I've just arbitrarily said that is the case. Okay, you can assume that to be the case, and that may have implications for you in terms of your database design. I'm not telling you exactly what the implications are, but hopefully you can deduce what that implication is. The grading spectrum, if you implement most of the GET requests, then you're in the 40 to 55 bracket. To get up to 55 to 75, you have to implement all of the HTTP GET request endpoints, except for the translation one, because that's a little bit trickier to get working. In the 40 to 55, you also have to support the add a new review endpoint. In the 55 to 70, all of the GET requests, the POST request, and the PUT request. So the user needs to be able to update a review. The security stuff comes into relevance here. So the Cognito stuff, if you want to get him in this grade band, you'll need to incorporate the Cognito. And I really think it's not until you looked at the Cognito lab that you will be able to appreciate how you do that. For the very top grading spectrum, 75 plus, I'm saying that's where you need to be able to implement the review translation feature. And I'm also mentioning here, in terms of infrastructure, you can either implement what are called Lambda layers, which I have not covered and won't cover, so you need to read up on that, or you implement what's called a multi-stack app, which I haven't looked at either. Any of the apps that CDK apps that we've looked at are single stack applications, but you can break an application up into multiple stacks. So you need to read a little bit about that and then just arbitrarily break up your application up into 2 or 3 stacks. Now, where are we in time? I am also going to require everybody to sit what I'm calling a follow-up assessment, which will be a formal practical based assessment based on the assignment. And in this follow-up assessment, I will ask you to make a change to your application, and I'll be specific. I'll say exactly what change I want you to make. And you will have to complete that change in a 30 minutes. I'll give you 30 minutes to do it in the labs. So that will happen after the official hand up date for this assignment is the 15th of, what did I say it was? The 15th of March. So as soon as I possibly can after that date, that's when the follow-up assessment is going to happen. And that will take place in the lab. And it'll only be a 30-minute assessment. And the purpose of the assessment really is to satisfy me that you fully understand everything in the assignment that you have submitted. So it shouldn't be really a challenge for anybody, this follow-up assessment, provided you've done the work for the assignment itself. At the end here, I'm just giving you, I'm suggesting, obviously you, as with any programming assignment, you should kind of approach it in an incremental fashion. And I'm just giving you a possible incremental strategy here, which you can completely ignore it, or you can try and follow it. So I'm telling you how you might roll out this assignment implementation step by step, and I'm giving you the steps here in order, which you may or may not find useful. It's just I'm just trying to help you to break this down into a number of steps that you should follow in order to complete it. Okay, that's it. I'll pause for a second in case there are any immediate questions. I'm sure you're going to have questions later on, though, in the labs or on Slack, and that's okay. But for now, if there are any immediate questions. No. So what you need to do this week is you need to work your way through this lab. And by the way, this lab also needs to be handed up. So this is the second lab that you will be handing up. And I think the deadline is the coming Sunday. So work your way through this lab. Then you will be in a position to start looking at the assignment. And in next week's lecture and next week's lab, you will have a better understanding of AWS Cognito. And at that stage, then you have all of the knowledge that you need to complete the assignment. Okay, there aren't any questions for me, so I'm going to leave it at that, and I will talk to you on Friday. Thanks, bye-bye.